Okay.
Ezlan, can you see my slide?
Yes.
Okay, thank you, Ezlan. Okay. Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Okay, class, I think we can proceed with our lecture 4. We will continue our lecture 4, which is about entity relationship modeling, or ERM. For learning objective, overall we have 4 main learning objectives for this lecture 4. In this lecture 4, the student will learn about the main characteristic of entity relationship components, which is what are the main characteristics of ERC. The second one, how relationship between entity are defined, refined, and incorporated into the database design process, this is all about how we model the relationship between entity. The third one is how ERD component affect database design and implementation. The last one is that real-world database design often require the reconciliation of conflicting goals, which is for the last one, you will learn about the challenges of the database design. Entity relationship model. Actually, what is entity relationship model? The ERM is the basis of entity relationship diagram, and ERD define the first is conceptual database as viewed by end user, which is where the ER model refer to a specific table row as an entity instance. The second one is database main component. We have several components of the database. First is entity, and then what is an entity? An entity is an object of the interest that the end user. Example of entity, we have a student, a professor, class or course, and so on. And in ER notation, entity name is a noun, usually written in capital words. The second component of the database is attribute. What is attribute? Attribute are the characteristic of entity. Example, student name, student ID, student address is example of attribute for student entity. The third one is a relationship. What is a relationship? Relationship is an association between entity. Example of relationship is professor teach class. Professor teach class is example of relationship between professor and class. And teach is an association between entity professor and entity class. And then entity normally refer to entity set and not a single to a single entity occurrence. In other words, entity in ERM is correspond to a table, not to a row. First is attribute. What actually the attribute? An attribute is the characteristic of entity, where every entity must has attribute. There are several type of attribute that we have. First is required attribute. What is required attribute? Required attribute is attribute that must have a value, and in other words, it cannot be left empty. For example, attribute student name is an example of required attribute for entity student, because all the student must have a name. The second is optional attribute. Actually, what is optional attribute? Optional attribute is an attribute that does not require a value, which can be left empty. For example, attribute for number can be an optional attribute for entity student because the student may don't have a phone number. Domain and the domain. What is the domain? Domain is a set of possible value for a given attribute where attribute must have a domain. For example, the domain for attribute gender consists of two possibilities, which is male and female. Male and female is an example domain for the attribute gender. Another example is grade. For example, the domain for attribute grade is between 0 to 4, which is the lowest grade value is 0 and the highest grade value is a 4. So 0 to 4 is an example of domain for a given attribute. And then we also have identifier. What is identifier? Identifier is one or more attribute that uniquely identify each entity instance. For example, in relational model, identifier are called a primary key. Maybe some example for primary key for student entity is a student ID. Okay, this is just example for identifier, but you have to know what is identifier. Based on this statement, identifier is one or more attribute that uniquely identify each entity instant. We have a figure 4.1. Figure 4.1 show the attribute of student entity. We have two type of model here for that represent entity for student, which is Chen model and Crawford model. Based on this ER model, we have entity. We have one entity called student. For entity student, we have several type of attribute for entity student, which is student last name, student first name, student initial, student email, and student phone number. Based on this model also, we can see about the required attribute. What is required attribute here? And then the example of optional attribute here, and also the example of identifier. So for student last name and student first name can be are example of required attribute for entity student. Why? Because all the student must have student name or student first name or student last name. So student name is can be considered as a required attribute for entity student. Example for optional attribute, we can see here student phone number or student email. Student phone number or student email can be an optional attribute for entity student because maybe the student don't have a phone number or email right now. Okay, so this is the example for attribute, optional attribute for student entity. And then we also have identifier, and then here we can use identifier student initial as an identifier or as a primary key for student entity. So based on this model, we can see here what is a student, what is optional required attribute, optional attribute, or identifier for student entity. Class, can you mute? Class, I heard some voice here. Can you mute your mic? Okay, continue for attribute. For the identifier, we have composite identifier. What is a composite identifier? Composite identifier is a primary key that composed of more than one attribute, which is several attributes are selected to be the primary key. For example, for class entity, we have attribute like class code, course code, class section, and so on. So we can use class code and class course code as the composite identifier to identify each of the class entity instance, instead just using a primary key, which is class code. That is a composite identifier. But the important one, you have to know what is actually the composite identifier. Okay. And then for composite attribute, we have several type of attribute. First is a composite attribute. Composite attribute is an attribute that can be subdivided into yet additional attribute. For example, attribute address can be subdivided into several fields like a street, city, state, and zip code. So composite address is example of composite attribute for entity class, okay, entity student. And then we also have a simple attribute. What is a simple attribute? Simple attribute is an attribute that cannot be subdivided. For example, attribute age, sex, and material status can be classified as a simple attribute for a particular entity. And then single valued attribute. What is a single valued attribute? Single valued attribute is an attribute that has only a single value. For example, attribute ID number can have only one value attribute. Another example is attribute product part can have only one serial number. So a single value attribute is any attribute that has only one single value only. So we call, if the attribute that has only one single value, so we call attribute as a single valued attribute. And then we also have multi-value attribute. What is multi-value attribute? Multi-value attribute is an attribute that have many value. For example, attribute person may have several college degree, or attribute household may have several phone number or several phone types, and so on. So here we know already about what is a composite attribute, simple attribute, single value attribute, and multi-value attribute. Okay, we have figure 4.3 show that a multi-value attribute in an entity. We have Chen model and we have Crawford model here. So based on this ER model, for example, for car entity, the attribute for car color can be split to create a new attribute, which are car rim color, or car body color, or car top color, and etc. So car color can be an example of multi-valued attribute for car entity. And in chain notation, a multi-valued attribute is indicated by a double line connecting to attribute and entity. So if you see double line that connecting attribute and entity, we can know that attribute is a multi-valued attribute. Still about attribute, okay, class. For multi-value attribute is an attribute that have many value and require creating several new attribute, which is one of each component of the original multi-valued attribute. For example, attribute car color, we can create several new attribute for car color attribute, like car rim color, car body color, and car lamp color, as I said earlier. And then multi-valued attribute also creating a new entity composed of the original multi-valued attribute components. And then for the derived attribute, what is a derived attribute? Derived attribute is an attribute that whose value is calculated from other attribute, usually by using the algorithm. We will see example for derived attribute next slide. Okay, class. And then actually for derived attribute, the important one to use algorithm to derive that attribute. Okay. This is figure 4.6 definition of a derived attribute, and we can see here based on Chen model, based on this figure, an employee H attribute can be as an derived attribute for employee entity, where example employee H may be found by computing the integer value of the difference between the current date and the employee date of birth using some algorithm. So if employee H is derived from integer plus employee date of birth, we can say that employee H is a derived attribute. Please remember, in Chen notation, a derived attribute is indicated by a dashed line connecting the attribute with the entity. For example, here you can see a dashed line that connecting attribute employee H and entity employee. Okay, so here directly we can see which one is a derived attribute. But for crowd vote model, there is no way to distinguishing between derived attribute with the other attribute. So only in Chen model we can see the differences between derived attribute and other attribute, which is derived attribute represented by indicated by dash line. Okay, here let's see for example. And then table 4.2, we have advantages and disadvantages of storing derived attribute. So this in this table show the advantages and disadvantages of storing or not storing the derived attribute in database. So for example, advantages, the advantages of storing storing the derived attribute in database, we have a safe CPU processing cycle. This is some advantages for storing derived attribute in database. Okay, we also have safe data access time, data value in readily available, and so on. So I think I hope you can read and understand what is the advantages and disadvantages of storing or not storing the derived attribute in the database. We move to relationship in ER model. Okay, association between entity that always operate in both directions. This is a relationship. So a relationship is an association between entities that always operate in both directions. Each relationship is identified by name that describe the relationship. For example, we have, for example, a student. For example, student take a class. Student take a class is example of relationship in ER model. Student is entity, class is entity, take is a association between entity student and entity class. So overall, a student take a class is example of relationship in ER model, relationship between student and class. Another example, like a professor teach a class. So professor a professor teach a class is also example of relationship in ER model, where professor is an entity, class is an entity, teach is a association between entity professor and entity class. For participant, okay, what is a participant? The entity that participate in a relationship are also known a participant. So participant is the entity that participate in a relationship. So participant is the entity that participate in relationship. For example, in a student take a class relationship, in a student take a class relationship, entity student and class are participant. Okay, so for another example, in a relationship, a professor teach a class. So a professor teach a class is example of a relationship in ER model, and so entity professor and entity class are participant entity. So you have to know what is a participant entities. Okay, and then for connectivity, what is a connectivity? Connectivity is describe the relationship classification. For example, the relationship may be classified as one-to-one, one-to-many, or many-to-many. This is a connectivity. And then we also have a cardinality. What is a cardinality? Cardinality expresses the minimum and maximum number of entity occurrence associated with one occurrence of related entity. So we will look example, what is a participant entities, what is a connectivity, what is a cardinality. This is for figure 4.7 is an example of connectivity, cardinality, and participant in a relationship. So based on this model, we can say that professor and class is a participant entity, and then the relationship here is here we have a relationship. The relationship here is a professor teach class. Professor teach class is a relationship. The cardinality here, we can see the cardinality 1, 4. Here indicate that the number of class that professor teach is at least 1, but not more than 4, which is the professor which is professor can be teach 1 minimum at least, and the maximum one is 4, not more than 4. And then for the cardinality 1, 1 here is indicate that each class is touch 1 and only 1 professor. Okay, cardinality 1, 1 here indicate that each class is touched by 1 and only 1 professor. This is a cardinality. And then we have connectivity here. So if, based on this model, the connectivity here indicate that we have one-to-one relationship, and we have one-to-many relationship. Based on this figure, or based on this diagram. And then we move to existent dependent. What is existent dependent? We have existent dependent, and we also have existent independent. And an entity is said to be existent dependent if it can exist in the database only when it is associated with another related entity occurrence. Okay, that is existent independence. And then for existent independent, if an entity can exist apart from one or more related entities, it is said to be existent dependent. Usually, existent dependent entity is referred as strong entity or regular entity. So we will look in detail example of existent dependent and existent independent in the next slide. We move to relationship strength. For relationship strength, we have weak relationship and relationship. A weak relationship exists if the primary key or PK of the related entity does not contain a primary key component of the parent entity. In the next slide, we will look more detailed example of weak relationship in the ER diagram. Okay, and then for a strong relationship. A strong relationship, also known as identifying relationship. A strong relationship exists if the primary key or PK of the related entity contain a primary key component of the parent entity. This is a strong relationship. So you have to know what is a weak relationship and what is a strong relationship for the ER model. Okay, figure 4.8 show the weak relationship between course and class. Based on this diagram, we have course and class entity, or we have course table or class table. Under course entity, we have attribute like course code, department code, cost description and cost credit. Under class entity, we have attribute, class code, course code, class section, and so on. The primary key for course code, the primary key for course entity is course code, and the primary key for class entity is class code. In this case, a weak relationship exists between course and class entity because class code is the primary key for class entity, while course code in class entity is only as a foreign key. So the class primary key did not inherit the primary key component from the course entity. Here, course entity is a parent entity. So you can see from this figure, or from this example, is from this diagram is example of a weak relationship between entity course and entity class. Figure 4.9 is example a strong relationship between course and class. Based on this diagram, we have a course and class entity. Under course and class entity, we have several attributes for each entity. So you can see here the primary key for course entity is course code, and the primary key and foreign key for the class entity is course code and class section. So in this case, a strong relationship exists between course and class entity because the composite primary key of the class entity is composed of course code and class section. So and the course code in class entity is also a primary key to the course entity, which is a parent entity. So based on this example, we can see here the relationship between course and class entity is a strong relationship. Okay, strong relationship. We move to weak entity. What is a weak entity? A weak entity is an entity that meets two conditions, which are first, existence dependent, which is that is the entity cannot exist without the entity with which has a relationship. And then the second condition is the entity must have a primary key that is partially or totally derived from parent entity in the relationship. So for the weak entity, the database designer will determine whether an entity is weak or not based on a business rule. Okay, this is a condition of weak entity in the particular relationship. Okay. Figure 4.10 is example of a weak entity in an ERD. Okay. Based on this Chen model, okay, you can see, for example, we have an employee here. Let's say we have example for weak entity, which is dependent, is weak entity of employee of this relationship. Okay, because based on the definition of weak entity, you can see here in this under dependent, the primary key for dependent is department number and employee number. Sorry. Weak entity. Okay. This is this one is show the strong relationship between employee and dependent entity, but independent entity itself is example of weak entity, because the entity cannot exist without the without the employee. This entity dependent cannot be exist without the entity employee. Okay. I hope you understand, class, the definition what is a weak entity. Okay. This is example of weak entity, but this is also example for strong relationship between employee entity and dependent entity. Normally for a Chen model, weak entity indicated by this double wallet entity rectangle. Okay, this double wallet entity rectangle. If you see the double wallet entity rectangle, it means that the entity is a weak entity. Okay, we move to this is weak entity in a strong relationship. Why we said that strong relationship, the relationship between dependent and employee is a strong relationship? Because based on this one, you can see here, based on this table, you can see that primary key or foreign key of entity dependent is composed of two attributes, which is department number and employee number. Based on this, okay, primary key and foreign key for entity attribute, entity dependent, composed of two attributes, which is department number and employee number, and the employee number was inherit from employee entity. Okay, so and then employee number is a PK of employee entity. So based on this definition, the relationship between employee and entity and dependent entity is a strong relationship. Okay. because you can see also based on this you can see here employee number in the table dependent table also have here 1001 and also have here under employee table 1001. Okay, yeah, 1001 we have 1001 under employee table. We have also under dependent table also we have 1001. So based on the definition of a strong relationship, we can say that relationship between employee entity and dependent entity is a strong entity. But using this diagram, we easy for us to see clearly the strong relationship between employee entity and dependent entity, because we can see here the PK and FK for dependent here inherit from employee table, which is employee number is FK PK for dependent entity, where employee number also have is a primary key for employee entity. Okay. So we move to relationship participant. What is a relationship participant? Participant in relationship is either optional or mandatory participant. For optional participant means that one entity occurrence does not require a corresponding entity occurrence in a particular relationship. Okay, and then for mandatory participant means that one entity occurrence requires a corresponding entity occurrence in a particular relationship. So the existence of mandatory relationship indicate that the minimum cardinality is 1 for the mandatory entity. Okay. This is a Crowdfoot symbol. We have table 4.3. This is a symbol that will be used in Crowdfoot model of ER diagram. Okay, based on this table, first symbol for cardinality, first symbol is for cardinality 0n, which is 0 or many, where the many side is optional. And then for the second symbol, for cardinality 1 many, 1 or 1n, cardinality symbol for this 1n or which is 1 or many, the many side is mandatory. The third symbol is for cardinality 1 1, where 1 and only 1, which is the one side is mandatory. And then for the fourth symbol is for cardinality 0 1, where the 0 or 1, where the one side is optional. Okay, this is the symbol that will be used in Crowdfoot diagram. Okay, Crowdfoot model. This is example of Crowdfoot model. Figure 4.13 is a class is optional to course. Why class is optional to course here? Because we see the optional side. Okay, many symbol for this symbol, the many side is optional, and then for this symbol, the one side is optional. Okay, based on this Crowdfoot model, for example, course generate class. Course generate, we have a relationship for course generate class. We note that at least here one course do not generate a class. Therefore, the class entity is considered to be optional to the course entity, which is a course can generate for zero or many classes, and one class is generated by one course. This is example. Class is optional to course. Okay, class is optional to course. Just based on we can know from the symbol here, zero and or zero or many. Okay, where many side is a optional. Okay. This is figure 4.14, course and class in a mandatory relationship. Okay, based on this model, for example, we have a relationship course generate class. Course generates class. We can see here at least one course must generate a class, or each single class is generated by exactly one course. This is one to many, where one side one is mandatory, and this one many side is a mandatory. Therefore, the class entity is considered to be mandatory to course entity. A course must generate for one or many classes. One class is generated by one course. Okay, so this is example for mandatory relationship, because clearly based on Crowdfoot model, we can see whether the relationship is mandatory or optional. Okay. Okay, class, we move to relationship degree. What is a relationship degree? A relationship degree indicates the number of entities or participants associated with a relationship. We have three types of relationship degree. First is unary relationship. What is unary relationship? A unary relationship exists when an association is maintained within a single entity. The second type of relationship degree is a recursive relationship. What is recursive relationship? Recursive unary relationship, also known as recursive relationship, where the relationship exists between occurrence on the same entity set. So the second relationship degree is a binary relationship. So we have three types. Here we have three types. First, unary. Second is binary, and third is ternary, where recursive relationship is under unary relationship. So the second type of relationship degree is binary relationship. What is a binary relationship? A binary relationship exists when two entities are associated in a relationship, which is the binary relationship are most common of relationship in ER model. And the third relationship is a ternary relationship. What is ternary relationship? A ternary relationship exists when the entity are associated in a relationship. Means that a ternary relationship applies an association among three different entities. And then we will look example for unary relationship, binary relationship, and ternary relationship in this slide. Okay. We have a figure 4.15 where three type of relationship degrees. We have unary relationship here for the first diagram. The second diagram is binary relationship, and the third diagram is a ternary relationship. Based on this diagram, owner relationship is from employee to employee. Here, the relationship is the association between entity employee is managed. Okay. For example, an employee within employee entity is a manager for one or more employee within the same entity. In this case, the managed relationship means that employee requires other employee to be manager. That is, employee entity has relationship within itself, also known has a recursive relationship. So here, the association between entity is a managed. The example of relationship is employee manage employee. This is for the first diagram. For the second diagram is a binary relationship. Binary relationship is between two entity. Here we can see here, teach is a association between entity professor and entity class. We already know that a binary relationship exists when two entities are associated in a relationship. The relationship a professor teach one or more classes in this diagram represent a binary relationship, or is an example of binary relationship. And for the third diagram, which is we have three entity, which is a doctor, patient, and a drug entity. This is a ternary relationship. Ternary relationship applies an association among three different entities, which is a doctor, patient, and drug. Example here, we can say that a doctor write one or more prescription. A patient may receive one or more prescriptions. A drug may appear in one or more prescription. So this is for the third diagram show that the ternary relationship among three different entities. Okay. Figure 4.17 is example of ER entity relationship representation of recursive relationship. For recursive relationship, we have one-to-one relationship within same entity. We have one-to-many relationship, although within one entity, and we have many-to-many relationship also in one entity. So for unary relationship, we have different type. We have different cardinality, which is one-to-one relationship, one-to-many relationship, and many-to-many relationship. For diagram, for the first diagram, is an example of one-to-one unary relationship. Example, maybe we can express by an employee may be married to one and only one other employee here. Okay, an employee is married to one and only one other employee. Where is my cursor? Okay, yeah. Okay, see. Okay. And then for the second diagram is example of one to many ownery relationship. In this example, we can express by employee may manage many employee. Okay, one employee may manage many employees. This is one to many relationship, or each employee is managed by one employee. So because maybe one employee is a manager that manage many employee, and or one employee as a worker is managed by only one employee, which is manager. Okay, and then for the third diagram, show that M to M relationship, or many to many relationship. Okay, many to in this third diagram, we can maybe we can express by each course may have many other courses as prerequisite, or and a course, one course may be a prerequisite to many other courses. Okay, this is example of recursive relationship for many to many relationship. So we have one-to-one relationship, we have one-to-many relationship, and we also have many-to-many relationship in recursive relationship. We move to associative entity. What is associative entity? The associative entity is also known as composite or bridge entities, which is composed of the primary key of each of the entities to be connected. The associative entity is used to represent an many-to-many relationship between two or more entities. Associative entity also is in one-to-many relationship with the parent entity, which is the associative entity is composed of the primary key attribute of each parent entity to be connected. And associative may also contain the additional attribute that play no role in cognitive process. This is associative entities. This is how figure 4.23 converting the M to M relationship into one to M relationship. Okay. How we can convert from M to M relationship into one to M relationship. Okay, based on this figure, here we have three tables, which is student table, enroll table, and class table. Maybe we can consider if we just consider between student and class table, a class may be exist at start of the registration process, even though it contain no student. Okay, therefore, if we examine the relationship between student and class at the beginning, is a M to M relationship, which is the relationship a student can enroll several classes and a class is enrolled by several students. And then for the second table, you can see a class can occur more than one in enroll table. Example, class code, which is 10014 occur twice in enroll table, and occur only one in class table. Okay, for class code 10014. This reflects that the relationship between class and enroll is one to many. And then based on this table, also in enroll table, student number, which is 321452, occur three times. But on the other hand, occur only one in the student table. So if you look here, student with student number 0 to 1452 occur three times, okay, in enroll table, but only one time in student table. So therefore, the relationship between student and enroll table is one to many. So this is how we can convert the many to many relationship to be to one to many relationship. Okay. For figure 4.25 shows a composite entity in an ERD, which is enroll entity. Enroll entity is a composite entity. Based on the figure 4.25, we can see here the composite enroll entity is existent dependent on other two entities, which is student and class entity. We can see here the enroll table entity key, which is PK, primary key, and foreign key, which is class code and student number, is composed entirely of the primary key of the class table, which is student number and student number, and student table, which is student code and student code. Therefore, we can see here no null entries are possible in enroll table key attribute. This is example. This is example of composite entity in ER diagram. Okay. But the important one is you have to know what is a composite entity by definition that I given you earlier. Okay. Developing an ER diagram. The developing or building an ER diagram usually involve the following activities. Okay, first, create detailed narrative of the organization description operation. What is a detailed narrative? The detailed narrative of the organization operation is about a detailed description or a detailed explanation about the whole process of the organizational process, and usually in detailed explanation. Okay, example of organizational operation is like service delivery, teaching process, and production process, and etc. This is first step of developing or building an ERD. Okay, and then after create a detailed narrative of the organization description operation, you have to identify business rules based on the description. And then what is business rules? Example of business rules is an employee can be assigned to many projects. This is example of business rules. So after you create a data narrative, you have to identify which one is a business rules. Another example, okay, however, a single project can have multiple employees assigned to it. Okay, this is an example of business rules. Okay, after you create narrative, detailed narrative of organizational operation, you have to identify business rules based on that description. After you identify business rules, you have to identify the main entity and relationship from the business rules, or from the detailed narrative of the description. You also can identify what is the main entity and the relationship that exists in the particular description. Okay. Example of entity for the business rules given is a project entity and employee entity. So we have project entity, and we also have employee entity. Example for business rules is an employee can assign to many projects. So based on this rule, we can identify what is entity in this business rule, and what is the relationship exists in this business rules. So the entity that we can see from this example is employee and project, and then the relationship that we can see here is like employee is assigned to a project. This is example of relationship. So I said again, example of business rules is an employee can be assigned to many projects. This is an example of business rules. Based on this business rule, we have to identify the entity. So based on the business rules, the entity is a employee, can be employee, and a project. So based on these business rules, we also need to identify the relationship between this entity. So we have entity project, and we also have entity employee. So what is the relationship between project and employee? So the relationship between project is employee is employee is assigned to a project. Okay, this is example. And then after that, after you identify
tinggi satu kat mana?
After class, can you mute? Okay. After you identify entity and relationship based on your business rules, you have to develop the initial ERD. And then after that, you identify the attribute. After that, you identify the attribute and primary key that adequately describe entity. And then lastly, you can revise and review your ERD that you already drawn. Okay. So class here, I give a link that you can refer to. The link is related with a video on YouTube. So you can refer to this link on how to develop an ER diagram. This is the example that the instructor give to you how you can develop your ER diagram. This is, we have a YouTube here. You can click, and the YouTube the video we played and will be played, and you can see. Okay, and then maybe you can try later. We move to example. Figure 4.26 is an example of ER diagram for Tini College. This is the example. We have overall we have 9 segment of Tini College Tini College ERD for Tini College. 9 segment. The first segment of Tini College ER for Tini College is this one. For figure 4.26 is an example of the first ERD segment of Tini College. And based on this figure, we can see here we have three entities, which is professor, school, and department. Okay, class. Before this is actually step 4. Develop the initial DID. Step 1, you must create the detailed narrative description. Step 2, you identify business rules. Step 3, you identify main entity and relationship from the business rules. And step 4, you develop the initial ERD. Okay, and this is step 4. Actually, after you identify, after you create a detailed narrative, identify business rule, identify relationship, you create, and then based on this diagram, we have 3 entities here. This is just example. Okay, class, just example for Tini College. Okay, this is first ERD segment for Tini College. It's just example. Okay, we also have here. We also have 2 relationship, which is professor is dean of school and department operate school. Okay, and we have here one-to-one relationship and one-to-many relationship. Okay, one-to-one relationship and one-to-many relationship. And then for the figure 4.27, figure 4.27 is the second ERD segment of Tini College. Okay. Based on the figure, you can see that we have 2 entities, which is department and course, and then we also have one relationship between department and course, and then we have the relationship between department and course is a department of course. This is relationship. Okay, and then example of relationship. And then here we have one-to-many relationship between department and course. Okay. And then this is for figure 4.28, example of third ERD segment of the Tini College. And then same also based on this figure, we have 2 entities here, which is course and class entities. And then we have one relationship between course and class. Relationship is course generates class, and then we have one-to-one, one-to-many relationship. Okay, one-to-many relationship between course generate class, and we have the cardinality is 1-to-1 and also 0-to-many. Okay. This is the 4th ERD segment of the Tini College. Okay, here we have 2 entities and with 2 relationship. Okay, and then for the relationship we have one-to-many relationship and we have one-to-one relationship. Okay, and then for the type of relationship is department employee professor. And then professor chair department. This is the 4th segment of Tini College ERD. Okay, and then figure 4.30 is the 5th ERD segment, example of 5th ERD segment of the Tini College. We have still 2 entity, one relationship, which is professor teach class. We have one-to-one relationship and so on. Okay. Okay, this is the example of the 6th ERD segment of Tini College. We have 3 entity here, which is student enrolled in class and so on. Okay, you can refer to your okay, the relationship between is student is written in enroll, and class is found in enroll. This is example of student relationship between student to enroll, and relationship class to enroll. Okay, and then we have one to many relationship between student to enroll and between class to enroll. And then this is the 7 example for the 7 RD segment of Tini College. Okay, still we have 2 entities, and we have one relationship, and then between department and student, and we have one to many relationship here. And then this is the 8 example, the 8 Tini the example of the 8 ARD segment of the Tini College. We have professor and student as an entity, and we have advice is association between professor and entity. The relationship between professor and student is a professor advice student. Okay, and we have one to many relationship between professor and student. And then lastly, we have the 9th example of 9 RD segment for Tini College. And then based on this figure, we have 3 entities here, which is boarding, room, and class entity, where we also have 2 relationship between boarding to room, and between room to class. And then if you look here, you have content is an association between building and room, and is used for is association between entity, room, and class. The example of relationship is building, content, room. And another example is room is used for class. And then we have one to many relationship. Plus, overall, table 4.4 is overall the component of ERM of the Tini College. So we have several entities. Okay, from first segment until 9th segment, we have several entities, which is school, department, course, professor, student, building, and room. And then we have several relationship, which is operate, has employ, offer, generate, is dean, chair, teach, advise, enroll, contents, issues. And then we have several connectivity, which is 1 to M, 1 to M, 1 to many, 1 to 1, many to many. Okay, and then also we have the connection, the relationship between each entity. Example, school, operate, department. The connectivity relationship is 1 to many. Department has a student. Relationship has, and then the connectivity 1 to M. And then department relationship for department employs professor with the connectivity is 1 to M, and so on. Okay. This is overall complete ERD for Tini College. Okay, after you merge all the segment, because you have easy for you to for the large case, for the large business, maybe you can develop ERD segment by segment. After you develop ERD segment by segment or case by case, you can combine all the ERD to be one complete ERD. How you can, what is a segment actually? This is the segment is also can refer a single of business rules. Every business rules you develop their own ERD. Let's say you have 9 business rules. So from 9 business rules, you identify what is entity and what is relationship in that business rules, and the cardinality, and then you develop ERD for each business rules. After that, after you develop the ERD for each business rules, also call each segment, and then you merge together to be a complete ERD, and then try to match with your narrative of the organizational operation. So this is overall of how you can develop or how you can construct your ERD model. But for your exam purposes, no need to develop ERD based on segment, because maybe in your final exam, in your exam or your midterm, the case study is quite simple and short. You just identify the entity, identify the relationship, identify the cardinality, and you develop just develop. No need to separate your ERD development based on a business rules or based on a segment. Sorry, class. Berhenti sekejap, minum air. Okay, we can continue. Okay, last slide is a database design challenge, which is conflicting goals. The database design often requires the reconciliation of conflict goals, and then the database design challenges in the real world include, based on this slide, first, database design must conform to design standards. So the design standard allow you to work with a well-defined component and to evaluate the interaction of those components with some precision. Without design standard, it is possible for you to formulate the proper design process, or it is possible for you to evaluate the existing design or to trace logical impact of design, of changes in the design. Okay, this is the first challenges. Database design must conform to design standards. Okay, the second challenges is need for high processing speed may limit the number of complexity of logically desirable relationship. For example, in a big organization, those generating large number of transactions, high processing speed are often a top priority in database design. High processing speed means minimal accessing time, which may be achieved by minimizing the number and complexity of logical desirable relationship. So this is the second challenges for designing the database in the real world. Okay, but in your case, this is the real world. Okay, we talk about big organization. Okay, and then the third challenges is need for maximum information generation may lead to loss of clean design structures and high transaction speed. This is because the complex information requirement may detect data transformation and they may expand the number of entity and attribute within the design. Okay, therefore, the database may have to sacrifice some of its clean design structure and some of its high transaction speed to ensure maximum information generation. Okay, this is third challenges of database design. Okay, which is need for maximum information generation may lead to loss of clean design structure and high transaction speed. Okay, overall we have three database design challenges, but if you Google from internet, maybe you can find other challenges of database design. Okay. But overall, this is we have 3 overall. But maybe if you search through internet, we have SRL example of database design challenges. And then if the question asks, if the question that related database design is asked in your tutorial, no need. You can get the answer from internet. Also can, okay. And if your answer is different with this slide, don't worry, because maybe you can find other challenges of database design. Okay. Okay, lastly, this is figure 4.38, various implementation of one-to-one recursive relationship. Okay, this is because based on this diagram, you can see here we have several diagram. First is only one table. We have only one table. First implementation, which is the table name is employee. So employee is entity, and the second table we split the employee into two entity, which is two table, which is employee and merit table. Okay, and then for the first implementation, we stored all the information into one table. So if you store all the information into one table, if you store all the data into one table, we have several problems with that, with this way of stored of data. Because if you store data into one table, normally the problem is related with anomalies. Okay, anomalies, which is this is the poor method to store a data. Okay, you have to store your data into several tables. Okay, and then for first implementation, we have stored all the data into one table, and also we call a flat file database. Okay, and then if you see here, we have redundant data, which is we have the data about any John here, and also not redundant. Okay, this is an employee any John. I say the problem of the first implementation is, for example, if we see here any John have employee suppose 349. 349 is a Shapiro intern. So if we delete, let's say any John divorce Shapiro intern, we have to delete any John. You have to delete Shapiro employee spouse of any John, which is Shapiro, which is 349. If you delete this 349 from this row, you also need to delete for Shapiro Anton row, because if you just delete the row for any John, and you did not delete Shapiro Anton, this is called inconsistent data. Okay, so if any John divorce Shapiro Anton, you have delete two rows of data. Okay, So this we call deletion anomalies, an anomaly problem of deletion. And then to overcome this problem, you have to split your table into two tables. You have to store your data into two tables. Maybe you can name the table employee and the other one is merit table. So we have, of course, we have primary identifier for merit table to employee table. So however, this the second approach implementation still have a problem of duplicate value. For example, here the merit between employee 3, 4, 5. Okay, 3, 4, 5 and 3, 4, 7 may still appear twice in merit table, which is 3, 4, 5 and 3, 4, 7. Okay, 3, 4, 5 we have 3, 4. Here we have 3, 4, 5. Employee spot we have 3, 4, 7. Employee number 3, 4, 7. Employee spot 3, 4, 5. So we have duplicate of data. So this is the problem of the second implementation. So to solve the problem, the solution is the third implementation, where you split two tables into three tables, which is marriage table, marriage part table, and employee table. And then where we have the identifier, we have to identify the associative entity between merit and employee entity. Okay, merit and employee entity. So we have to identify the associative entity, which is the associative entity, which is a marriage part. This one, marriage part entity. Okay, in the third implementation. So from a flat file database or a single tables, we have several problems, and then we split the single table. We convert the single table into two tables. Also, we have a sub problem, which is redundancy of data. And then to solve redundancy of data, you have split two tables into three tables. Okay, which is we have add another table of associative entity between marriage and employee table. Understand, class? Okay, I think that's all for our lecture today, class. Okay, if you have a question or problem, I think you can answer. You can ask through tutorial class. Okay, in your tutorial class, you can ask the question. If you have a problem with entity relationship lecture. Okay, but I think that's all for now. Okay, I will pass this session to Dr. Fariza. Dr. Fariza is here. Dr. Fariza, are you here?
Ya, ada. Thank you, Dr. Khalid.
Okay, Dr. Fariza.
Suka suara you. Suka dengar you mengajar. Your suara very nice.
Okay.
Okay, thank you. Okay, hi students. Okay, apa ni? Actually, Khalid and Dr. Nujihan, please help me out ya, sebab kita nak discuss pasal apa ni project ni.
Okay.
Okay, so I'm going to take control of the screen ya. Siapa approve saya punya ni? Waiting for approval. Okay. Mana? trying to take, I'm going to do presentation.
Tak, saya kena keluar dulu.
Okay, alright.
Dah.
Okay. Okay, let's see. I want to show you my desktop. Okay, first of all, class, if you go to Spectrum, I already put up under the general section a folder. Can you see my screen? Dia nampak screen tak?
Nampak.
Boleh.
Alright. Okay, so dekat sini group project information. So here there are two files. One is more information about the assignment, and number two is when you want to go to the company, even though you have to go, maybe you have to meet with them online on Zoom or on Google Meet or Team or whatever, you still need to give them a letter lah. Yeah, so if you that is a template of the letter, so that you can once you have put in the information there, you need to ask us to sign the letter, okay, so for our approval. Okay, so what is on the assignment? Let's see. Okay, you go through. Yeah, you just go through. I won't go through every single thing, but you just go through. Okay, regarding the members, we still have to edit some of the members, because I'm not sure about other groups, but for tutorial 1 and tutorial 2, your group still not balanced. So I see there's still a few yang all one race or only one person. So I'm going to make notes for you to actually edit it a little bit. Yeah. So there are a few teams you need to just like reshuffle again. So find another team, because group 1 and group 2 you can mix together, because we are still in the same tutorial group, so it doesn't really matter, you know. So I think yang other like for maybe there are some groups under Dr. Nojihan or Dr. Khalid, maybe there's like too many of the same race or the same. So if you have that, if there with your lecturer's approval, maybe then you have to go with mixing of departments. Okay, so you don't want all network in one department and all IS in one department. You have to mix. All right, so that's also another way. But first and foremost, you have to get all kind of your international and Malaysian, and then Malay, Chinese, all Indians, all must mix together. Okay, that's number one. So we will finalize this, I think, soon lah, yeah, soon. But because maybe for my group, maybe on Thursday we will try to do something about it. Okay. So now, what organization can you go to? Okay, last time you go to a physical organization, but now you can still write in to them. Okay, and then maybe now you will have to. It's a little bit more challenging now, because you have to meet with them online, and then whether they have the time, and then whether they have the resources. But you know, you have to try. Yeah. So this is some examples. Last time, students, quite a number of them do go to college kelima, first college, second college, Ibn Sina college, or library, or or even though within UM you can go to those organizations. Okay, students usually ask me, can we do with an online business? They will say that I know this person who's running an online business. Okay, if it is an actual business whereby they have the needs for database, where they have real business rules, then you can meet with online businesses. However, I don't want you to dream up your own business. Like you sit with a few of your friends and you say, okay, let's try to imagine, or let's try to make up one online business. You know why I don't want you to do that? Because you are not yet experienced enough to know what are the issues of a business. You don't really know what kind of data a business would want. When students do that, at the end of the day, what we see is they will only see, like for example, if you do a business or online, selling phone covers or something like that, or phone accessory, they come up with something like that. So all they have is like customer, and then a customer buy something and then invoice, and that's it. So they have like maybe like three or four entities, which makes you can proceed with that. We don't have a problem. But if you look at the requirement down here, the assessment is based on the difficulty and scope of the application domain. Because we see students when they present their work, you have one group with only like maybe 4 or 5 entities, and then you have this other group who have like 12 entities, 15 entities. So of course, you know which one is going to get. I mean, and these systems are usually already running, because if it's not running, if there is problem, then they will not submit, right? So you have this big system, and then you have this 2 or 3, 4 entity. Of course, the one with the 2, 3, 4 entity will not be able to get an A, probably not even a B, so that's the thing. So you have to keep that in mind. So if you want to really do something which is worthy, go and get a real organization, and so that you don't have to think about what are the how the business is. You only need to think about how you get the information from the business, from the organization, and you just translate that into your database. Okay, so I know it's difficult, but try your best to get a clinic. Sometimes they work with, okay, my mother has a clinic, and we do that. Oh, that's fine, or my father is working here, and then work with what your father's company is doing. It doesn't have to be. And again, you need to look into scope of the problem. So for example, okay, let's say you want to build you have like, okay, my mother is a school teacher, so can we go and do a database for the school? Yes, but school has a very big it is a big organization, so there are many things, maybe information about the students co-curriculum, the classes, I don't know, maybe what do you call, assets, like each classroom got a kipas, got fan, got got TV, things like that. So what do you want to include? Everything? No. So you scope your organization. You only take on a certain part. Like for example, if I talk about University Malaya, you don't want to do everything about University Malaya. Maybe you just want to look at students registration and marks and courses, because there is another aspect of University Malaya, which is the college. So the college can be the residential also, maybe not everything, maybe because residential you have information on the administrative of the residential, meaning that the pengetua and the fellow and the kitchen staff, and then the kitchen staff's schedule, the fellow's schedule. Maybe you don't want to look into that, or maybe that's the one that you want to look into. So again, look at the scope. So at the end of the day, we expect your system to be maybe around, I don't know, 8 to not more than 12, 15 entities. But if you have less than 8, then it's too small. Okay, so think about that when you're choosing an organization to work with. Okay, and then so if you look through this, we have there are information about what you need to do. So basically, you will have a written report. Can you see my mouse? Can you see my mouse or not?
Tak boleh.
Ha?
Tak nampak.
Tak nampak mouse Mouse tak nampak. Okay, never mind. So if you see 2.2, design the database, you have a written report. So this is 15%, and then these are the things that you should include. Okay, and you can read on your own. And then video is also another 15%. Okay, and then video means you present your system. So once you have designed your system, then you have to implement on a DBMS. So you can use Oracle, because Oracle is the one that we will be basically putting some notes for you on Oracle. However, if you don't think you want to use Oracle, you want to use MySQL, I think we can allow, kan Dr. Jihan, we talked the other day.
Kita bagi. This depends on the student itself, as long as it is, can be Oracle or MySQL.
But if you want to use MySQL, you will have to do it yourself, because we don't have the capacity to teach you every single DBMS out there. But right now we are only limiting it to Oracle and MySQL. We don't want you to use Access, because Microsoft Access is it's not something that students will use after this. Student usually would choose MySQL or Oracle for their project lead, for their ilmiah. What do you call? Data ilmiah. Final year project. You know. So we don't want you to use Microsoft Access. It's either Oracle or MySQL. Okay, but the notes that we have on Spectrum, we will be giving you will be mostly on Oracle. Yeah, but because MySQL is like a lot of YouTube out there that you can actually look at. So so you need to go through this, look at this document first, and then have a feel of what is it that you need to do. And then so when you actually meet, when we finalize your group, I think next week you can start discussing with your friends before the term break. So you should be able, between week 5 and the term break, you should already be having already talking about it, already have your group already talking about it, and already approaching a few organizations, because not all organizations when you go and then they will say yes straight away. So you have to maybe have 1 or 2 in mind, and then approach them, and then you can start like thinking on how to divide your work and so on. So somebody needs to be able to edit the video presentation, because each of you must present, and the video must not be longer than 10 minutes, not longer. If it's 10 minutes and after that we won't look at it anymore, because imagine there's so many of you and how many videos we have to look at. So 10 minutes, that's it. If anything other than 10 minutes, we will not look at the last few minutes that you have. So as somebody in your group must be able to do the editing. So each of you will record your own part and then send to your friend, to the person who's going to edit, and then he will edit, or she will edit and make it nicely into a 10-minute video. Okay, any questions? Okay, yeah, and then please note, 5% will come from your peer work evaluation form, which is PNC, which will be sent privately to us. So if you are not doing a good job, your team members may not give you a good may not give you a good marks. Okay, so and so this is sent to us directly. So other members, you will not know what your other group members are giving you marks, how much they're giving you, and then you can also mark your group members. So this is 5% of this is 5% of this plus your plus other things like your tutorial, whether you are actually submitting them or not, whether we see that whether you are actually involving yourself or not. Tutorial, basically, if you don't send in your tutorial, we won't mark your tutorial, because tutorial, like I said, is for you to actually understand. And then if you are like never in class, never attend class, and don't send tutorial, so you will lose marks from this evaluation. Okay, so any other question? Any questions? Bukan any other question. Do you have any questions or not? Class?
Doctor, I just want to ask, which one is easier to use, SQL or Oracle?
Actually, basically, it's the same, because I would say it's basically the same, because they all have their own challenges. But at the end of the day, both is Oracle. Like if you download the Oracle Express, it has a table, a GUI, graphical user interface. So you can actually build your table quite easily. SQL, MySQL, if you download the basic, it doesn't have the, it can, well, you know, I've used MySQL, I think like maybe a few times. So I find it, because I'm used to Oracle, so I find it a little bit more challenging. But if once you have used it, I think you will find it easy also. So it's up to you, because now you're just starting. So you are starting on a same what do you call, same level. So you don't know either one. So I think the challenges are the same. It's just that I think the challenges are the same. Because current MySQL is easier to, the configuration is also quite easy compared to last time. Last time I don't use MySQL because the configuration was quite difficult to do. I always messed up my what do you call? Sebut tak ingat dah. You know, but anyway, either way is fine. But like I said, the notes that we have is on Oracle, because we have not compiled notes on MySQL, because we started all this while. It's always been Oracle for this class. Because now because of the because we were having online and so on, so we are giving students the flexibility. Like you can either use Oracle or MySQL.
Okay, thank you, Doctor.
Anybody else? But please,
I would like to ask,
please.
Is there any specific deadlines for like each part, or we just hantar at week 13 one shot?
Yes, you just send week 13 one shot. Well, week 13, so by right, you do your report. You should do your report earlier, because your report will have your ER diagram. You have your business rules. So this one is like the first few weeks already. You can already do this, and then after you have your ER diagram, and then after you have done your normalization, then you build your tables, and you go and do your tables. You're going to do your project. You're going to do your implementation, and then when you have your implementation, then you will have you have to run SQL queries. So when you do your what do you call, implementation, you will have you must take screenshot of your table on your system. So you have your database system. So I want the tables to be screenshots from your system, not just tulis table in Excel and then put inside your report. I don't want. I want screenshots from your actual system, and SQL also must be from your actual system. Okay, so that is why you have to, even though you have done your report, half of it earlier, but when you can only get the screenshots after your system is ready. So you put the additional inside your report. So that's why your report is also due in week 13. You can look at the new course information. I've updated a few things, so you can go back and go back to Spectrum. You have the latest. You have also the dates on what is due, and then when is your summary. When is your alternative assessment? You will have 2 alternative assessments, so you can look at your course information and look at the dates. Any other question?
Doctor, I have one question. So are you going to review the team allocation and then let us know which ones need to change, or
the group, you mean?
Yeah, are you going to review it?
Yes.
Let us know.
Yeah, we are because, like, for example, I note here group 1F, we have Mahesh, you, Uy, Tan, and Muhammad Fairuz. I know you have 1 Malay, 2 Chinese, 3 Chinese, 1 Indian. But if you look at group 1C, 1C has all Malays. So 1F and 1C can actually just can try to reshuffle a little bit, and then there are a few things because if you look at it, you can reshuffle. So and then like group 2B, you have almost all international, Iran, Yemen, Bangladesh, UK, and then one from Malaysia. You can reshuffle that, so there's reshuffling that needs to be done. I will talk about it during tutorial. I will just orally inform you, because then you can just take note there and then. All right. Other groups, Dr. Najihan, Dr. Khalid, maybe you want to say something? Dr. Najihan?
For my groups, I think because I don't have, for group 6, we only have about 17 students. So basically, I will check again tonight whether we need to reshuffle the groups or not, because some of the groups, I think it is okay in terms of their members. It is already mixed, okay, but the rest I need to check.
Also from my group, I will check it again, and then I will inform maybe through tutorial whether we need to shuffle or not. But I think mostly okay, nampak macam okay is okay. But I will check it again.
Yeah, I think because for my group, I noticed group 2, there is so many, there are a high percentage of Chinese. Group 1 is like, I think, higher percentage of Malay. So that's why I say group 1 and group 2, now you have to mix. You cannot, you just don't look at, I'm in group 1, so I just find people from group 1. No, you will have to. So if you look at all in as a total, group 2 and 1, then it's more easier for you to actually mix the group up. Yeah. So what I would do is I will give you a chance to actually go and redo this first yourself by tonight or by tomorrow afternoon. Tomorrow night I will look at it again and then see, because I don't want to be telling you every single, like for example, group 2I. Okay, group 2I not so bad. No, yeah, group 2I also, group 2J, group 2G, group 2G not bad. Group 2E, and then group 1M, group 1C. So all this, if you just group 1I, all these so unbalanced groups. So just go and look for another group, and then the numbers are there, the phone numbers are there. You can very quickly, the phone numbers are, you have the always put your phone numbers, people, so that people can actually contact you if anything, and then you just quickly contact, or maybe email, or maybe just even on the chat or whatever. I'm going to give you a chance to do this again yourself, like I mentioned just now. Those of you in those groups, you know who you are, and then they are all, even if I don't mention your group, if you are very strongly predominantly one type of group, one type of people, so change that, because I think I can easily just change you around, but I don't want to change you around. You're not budak-budak, you can do this yourself. Okay, all right, class, anything else? Ada apa-apa lagi tak?
Doctor, one more thing. Are you gonna let us know how the mid-sem test is gonna be run? And like,
go download the course information. I've updated all that already. Look at the latest. Go to Spectrum.
But there was like the scope. There's no scope.
Okay. Midterm is week 6, right?
6.
Yeah, week 6 after. So it will be everything up to week 5.
Okay.
It will be an online. It will be on the Spectrum quiz platform. So it's not online, but it's not face to face. We will open the quiz up for a certain period, and then but once you open, But once you click open and once you start attempt, you only have like maybe 1.5 hours, I think, to complete the questions. And then after that, you can't submit anymore. So you can start maybe at 10, somebody may start at 11, but you only have, if you open up at 10, so you have 10 until maybe 11:30. So we don't want everybody to open at the same time because we don't want the system to crash or anything. So, a few people may want to do it like later in the evening, but you still have only that 1.5 hours to do it. I think it's 1.5, I'm not sure because we have not really finalized the midterm yet. Okay?
Okay, doctor, I have one question.
Hmm?
Since we'll be looking for an organization, right, to let's say like interview them about their database and stuff, so do we need like letters or something? Because I think some companies would ask for it.
Yeah, I tunjuk you just now kan dekat sini.
Yeah.
Here, letter to company.
I know,
see that?
but does it have like sensitivity agreement and stuff? Because for me, I'm going to analyze from the ETL part.
Right. Okay, look at this. Choose an organization. As I say, you got to go and read this first. Do not go into details about their system or databases. Just understand their workflow and data flow. You are not supposed to look at their data. Okay? You're not supposed to look at the data. You only need to ask them macam, okay, for example, I go to a clinic, right? Okay, you ask them, what kind of information that you usually need. Okay, and then they will say like, okay, we need to keep track of our medication. Who do we give our medication to? Things like that. So you capture all this business, and then so maybe you can say, okay, I look at your a form of what a form would look like, because the form would give you all the attributes. So you don't want to look at their data, so you don't have to have a non-disclosure agreement and so on. All right. So we don't want you to look at data. Understand not? Because if you want to go into non-disclosure disagreement, it will take forever. You will never get your work done. So here, this is the we would like to understand the workflow and data flow of your company, and we do not need to go into details or see any confidential parts of your system or your data. Okay? Is that clear enough for you? All right.
Just like asking from because I'm still very new to this, so asking the ETL process is considered confidential or not?
No, okay. Just put it this way, if they feel that it's confidential, then don't ask them. So it's okay then. If it's confidential, that's all right. So so we want to. You don't want to have to do the database exactly because so just do whichever that is doable. Yeah. If you think that this company everything is confidential, so never mind, move on to another company. So that's why I say you need to have to talk to a few companies and see how some companies may be a little bit so scared, everything also cannot show, everything also cannot, so don't work with companies like that. Yeah, because we have students who has worked with bookstores, MPH, and they never have any problem. Yeah, because let's say you go to a bookstore, you only want to know okay, if when your customer buy from you, how many books that they buy at one time. They will say that one time they can buy many books. So that is your business rule, right? One customer can purchase more than one item, right? One item can be purchased by more than one customer. So that you want to get that kind of understanding, that kind of rules, right? Because for example, if I go to a clinic, maybe this clinic will say something like, oh, our doctor, of course one doctor can see many patients, but that patient, whenever they come, they only see this one doctor. They cannot see other doctors. So that is a business rule. So this is a one. That means it is a one to many. One doctor, many patients, but one patient, only one doctor. So this is the kind of business rules that you're going to get from them. And then like I said, the attributes, then maybe you can look at the registration, empty registration form, you don't have to look at forms that has been filled up, things like that. Yeah. So workflow in terms of, how many people can, how many appointment can one person make at one time, or how many, those are not confidential. I don't think so. And if they don't want, they feel that everything is confidential, then you move on to another company, because there are a lot of other companies yang okay, no need, no need to be so strict. Anything else? Class, tak ada? Okay. So
sorry, doctor, just one more question. For letter, right? Do we have to submit it on Spectrum once we get you to sign?
I think, yeah, that's the thing. I think you, I'm not sure lah. Dr. Jihan, is it better put on Spectrum, or is it better kita put on Spectrum? Is better tak? Email aku tak baca email.
Email lah. I think okay, this is for the letters that they should provide to the company, kan? I think for me, I prefer them to send me the email so that I sign the letter and then send it back to them. Kalau saya lah, saya prefer macam tu.
Okay lah, yeah, I think email lah.
Right, so we have a WhatsApp group, so that maybe once you email, you told us that you have emailed us the letter, so that we aware of the email, then send it back to you.
Okay, thank you, doctor.
Email. Okay. All right. Anything else?
Yeah. Also, doctor, after we got the letter to be signed, do we have to put it in our project as an appendix? Yes.
If you go through the assignment information, you should also get some kind of acknowledgement from the company saying that you have to work with them, and put that in your appendix also. Okay.
Okay, thank you, doctor.
Ensure that you are actually working with a real company and not your angan-angan dream up company. Anyway, we will know if you're dream up company when we see your result anyway, your work anyway. So put it inside. Anything else? Okay, anything else you can also ask from the WhatsApp group or in tutorial. Think about it, and then masa tutorial on Thursday, you can just voice out your questions, okay? Alright, itu je Dr. Khalid, I'm done. Dr. Khalid tidur ke?
Oh, okay, class, I think we can. Okay, class, I think. Okay, class, I think we can close. Okay, class, thank you for your attention. Okay, class, bye. Thank you.
Okay, so next this Thursday we will have a face-to-face session, right, Dr. Farizal?
Yes.
Okay.
Yeah, betul.
Yeah.
Okay.
All right.
Okay, so thank you.
Okay. Bye.
Thank you, doctor.
Thank you, doctor.
Okay.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.